Welcome to the module of TrainMe. This module will help in understanding you more about welding. It includes different topics of welding in process industries. TrainMe module has been designed to make this software training free and provide basic knowledge. Hope you would find it useful and keep on running several videos to have in-depth understanding of welding. This is a short lesson on welding processes. There are 5 arc welding processes mostly used for process industries: shielded metal arc welding, gas tungsten arc welding, submerged arc welding, gas metal arc welding and flux core arc welding. The most commonly used are SMAW and GTAW. On the next slides, we will let you know about these welding processes. Shielded metal arc welding process is a manual welding process. Consumables include an electrode and a power source. A welder has to use the electrode to fuse the two materials with the supply of power. Current can be alternating or direct with electrode negative or positive. Electrode used in shielded arc welding contains shielding flux which avoids any oxidation of molten metal. Shielded metal arc welding is the simplest welding process. It requires less capital to arrange the starting necessary welding equipment. Electrodes availability is not a concern. Those are available almost for every material. The process is flexible to use in all positions. Field application is huge as it occupies lesser space. For limited accessibility areas, SMAW is the best process to use. With this welding process you can weld all base metal thicknesses from 1.6 mm and greater. Limitations of this process include the welder skill which is not easily attainable. However, welders do start their welding career with this process and with training become masters. As this process uses shielded or flux-coated electrode, therefore it requires cleaning after every few passes. Cleaning if not properly done with wire brush or grinder would result in slag inclusions. Then the other bottleneck of this not continuous process is electrode breaking. Electrode available in 12 or 14 inches length has to break after some time and a new needs to be put in. With all these factors the operator factor remains not greater than 25%. Operator factor is a measure of welder on the weld joint. In 1 hour, a welder can do welding with this process for only 25 minutes. Remaining 35 minutes will go in cleaning, electrode breaking, wire brushing and chipping. Overall weld quality also stays low if joint detail differs than the designed one. Polarity is one thing needs to be understood for arc welding processes. There are 3 different types. One is direct current with electrode positive, second is direct current with electrode negative and the third is alternating current. DCEP is also called reverse polarity and DCN is called straight polarity. Always remember when electrode is connected to negative terminal of the power source, it would be straight polarity. SMAW can be used with current ranging from 25 amperes to 500 amperes. Voltage range is from 15 volts to 35 volts. This table presents the amperage data for different electrodes used for SMAW process. You can refer to this table and use the recommended amperage if you are performing shielded metal arc welding of carbon steel materials. Here you can refer to the deposition rates you can achieve at different amperages. This data is only for most commonly used carbon steel electrodes. Gas tungsten arc welding includes a bare wire as a consumables along with heat and gas. Unlike in the case of shielded arc welding, gas is used in GTAW for shielding to avoid oxidation of molten metal during the welding. Tungsten rod is used to produce arc and heat is generated to melt the filler wire. This process is slower than shielded metal arc welding, however produces sound welds. It is normally preferred to perform root and the hot pass with GTAW. Gas used for this process can be argon, carbon dioxide, or mixture of the allowed gases as given in ASME Section 2 Part C. GTAW produces high-quality welds. This process results in low distortion and is free of spatter. It also provides a precise control of heat input and works with a range of power supplies. During welding, vision is not limited due to fumes or smoke. It can be used with or without filler metal. Limitations of GTAW include lower deposition rates compared even to SMAW. This process becomes less economical for thicknesses greater than 9.5 mm. It is challenging to weld with this process in drafty environments due to shielding issues, as shielding is done by gas. Normally, the gas flow rate for argon is kept at 15 cubic feet per hour. Here is a representation of welds made with GTAW with different polarity settings. Direct current electrode negative is recommended for GTAW. This demonstration also suggests that with straight polarity, DCN, you can have deep penetration. Submerged arc welding is a manual, semi-automatic and an automatic process of welding. Shielding is done by a separate flux arrangement. Electrode is fed by a machine and this process results in high deposition rate. Deposition rate is the rate of weld deposit and is measured in pounds per hour or kilograms per hour. This process uses high heat input. It is also to be noted that this process is hard to use in the fields or for smaller scale jobs. Its use is mainly within the workshops and when larger welding works need to be done. The biggest advantage of this process is the flux blanket which virtually results in no spatter, arc flash and fumes. This process results in high deposition rates and welding speed. Cost per unit of length is low as compared to other processes. Flux acts as a deoxidizer which results in low contaminants like oxygen, nitrogen and sulfur. This helps in obtaining very sound welds with excellent mechanical properties. Shielding in this process is way better than shielded metal arc welding. Also, this process requires minimal welder training. Submerged arc welding has its limitations also. Initial cost for setting up the welding equipment is high. Weld joints need to be placed in flat, horizontal positions to keep the flux positioned. Then slag must be removed before subsequent passes are made. And because of high heat input, it is normally not practical to weld below 6.4 mm of base metal thickness. Gas metal arc welding is a semi-automatic or automatic process of welding. Shielding is done by the gas continuous supply. Solid wire electrode is fed through the nozzle along with gas. This process also results in high deposition rates, however lesser than submerged arc welding. The first advantage of this process is that the welding can be done in all positions unlike submerged arc welding. Welding speeds and deposition rates are higher than shielded arc welding though lesser than submerged arc welding. It is a continuous wire feed process and there is minimal requirement of post-weld cleaning. Penetration is also deeper than SMAW process. Like submerged arc welding, it also required minimal welder training. Gas metal arc welding equipment is costly and complex. It cannot be used in hard-to-reach areas and very difficult to use in drafty environments. There it requires complete protection for effective execution. And due to arc intensity and high level of radiated heat, operator access is hindered. Flux cored arc welding uses a consumable, filler, which contains flux in its core. Outside is wire like in case of GTAW, but the inside of it is flux for shielding. Therefore, in this process shielding gas is optional. This process adds the advantage of continuous wire feed and the flux. It requires lesser operator skills than GMAW. It is much simpler than SAW and has high deposition rates compared to shielded metal arc welding but lesser than SAW. In flux cored arc welding, slag needs to be removed. This process generates more smoke and fumes compared to other high deposition processes like GMAW and SAW. Therefore, fumes extraction is required. The equipment for this process is complex and less portable. Here are the deposition rates for different welding processes. You can see that every welding process has its own range of deposition rate which depends mainly on the current. More the current, more the deposition rate. Submerged arc welding has the maximum rate of deposition among all the welding processes. This photographs has been taken from American Welding Handbook. We have come to the end of a lesson on welding processes which we hope you have understood. Do not hesitate to write to weld@weldpulse.com in case you need any support on WeldPulse software and its features.